this expression that you see right here, we want to try to factor it. So as with any time we're factoring things in math, we always want to check for a GCF first if there is one. So when we look at the terms of this expression, we've got 16 and 6, which would both share a 2 as their only common factor other than a 1, but 45 doesn't have a 2, so therefore there's no common factor, and they don't all have variables either. So yeah, for this one, there is no GCF. So then from there, when we think about this trinomial, we might think, oh, maybe, there's some stuff that we could FOIL out that would equal it, right? So the stuff that's at the beginning, that times that would have to equal the 16x squared directly. So we'd have to think like, could I do 16x times x? Or maybe is it 8x times 2x? Or is it 4x times 4x, right? And we don't really know until you just kind of guess and check, right? We also know that whatever's at the end of those binomials there would have to multiply to equal the 45. So you might do like negative 1 times 45 or 1 times negative 45 possibly, right? You also have like negative 3 and 15 or 3 and negative 15. You could also do negative 5 and 9, or you could do positive 5 and negative 9. So lots of options there for the 45 there as well. So it just becomes, right, a guessing and checking game, right? So like one strategy you could use is you could set up your binomials and think, okay, well, I think that maybe it's going to be the 16x and x, right? So you might try something and think, okay, so do I choose the 45, 1, 315, 5, 9, right? So maybe you try, okay, let's try plus 45, negative 1, right? You FOIL it out, and then it turns out for this one, you get a 29x, positive 29x in the middle. So obviously it doesn't work. So then you might try, instead of positive 45, negative 1, you might try negative 45, positive 1, or, switch them to the other groups or whatever. You might try the 315, 5, 9. If none of that works, then the 16x and x isn't going to work. So you'd have to try a different strategy, right? So maybe if it's not 16x and x, maybe it'd be like the 2x and like 8x, right? So maybe you, I don't know, plus 15 with a 2x, and then, I don't know, like, then have to be a negative 3, I guess, with the 8x, right? That one would actually give you 114x in the middle, which is definitely not the 6x squared that we want. So that wouldn't work either, right? So maybe if you wanted to go into the world of the 4x and the 4x, you could, try that route as well. Maybe you'd want to do like the 9 and the 5 minus the 9 plus the 5. That one would actually give you a negative 16x in the middle, which wouldn't work either, right? So you can see that just like with those 3 random ones that I just kind of picked out there, none of them work. And in reality, you might be sitting there guessing and checking all for a very long time. So it'd be really nice that whenever the beginning of a trinomial and the end of a trinomial, have lots of options of factors and stuff, it'd be nice if there's some sort of strategy that we could employ that would make this go a little bit more efficiently, a little bit faster rather than guessing and checking. And it does turn out that there is a way, and that's where this AC method of factoring comes into play, and it's really helpful for us. So the AC method of factoring helps us to factor trinomials, so really things that are of this form right here, where you've got ax squared plus bx plus c. So I'm going to exemplify that with this example that you see right here that's of that sort of quadratic form. All right, so our goal is to try to factor this, right? And we're going to use what's called this AC method of factoring to do so. Now, with any factoring, right, always we can factor out a GCF first. I say it a million times, and I'll keep saying it all the time, right? Whenever you're factoring, you can always factor out a GCF first, and you should, okay? So with this expression, 18, 15, and 12, they're actually all multiples of 3, and it turns out that 3 is the greatest thing they're all divisible by, so you can factor out a 3 from all of these terms. So when you do take out the 3, you're going to end up with 6x squared minus 5x minus 4 inside of that parentheses once we factored out the 3. All right, so now at this point, this is where we're actually going to now use AC method through the rest of these steps right here. And really what we're going to use the AC method on is we're going to use it on this trinomial right here. So just the 6x squared minus 5x minus 4 that's in the parentheses. So the AC method is called the AC method because we are going to use the number a, which is 6, and we're going to use the number c, which is negative 4, and we're also going to use the number b, which is negative 5. All of them are relevant for the AC method. So what we need to do is we actually need to find AC. This is why it's called the AC method. We need to find what AC is. In other words, A times C. So in this case, it's going to be 6 and negative 4 times with one another, which gives you an answer of negative 24. Okay? So once we find what the AC number is, then once we jump to this fourth step right here, we need to list all of the factor pairs of the product AC until we find the one that has the sum equal to b. So let me start with the first part that I just underlined right there. Let's find all of the factor pairs of AC. So these are going to be our choices. We want to think about all the factors that will multiply to equal negative 24. So our options could be like a negative 1 times a 24, or it could be a 1 times a negative 24. We also have negative 2 times 12, or 2 times negative 12. We can do negative 3 times 8, or 3 times negative 8. We can also do negative 4 times 6, or 4 times negative 6. So those would be all of the possible options. Now, from those, we want to find the one that has the sum that's equal to b. So remember that our b value is actually this value right here of negative 5. So if we're to sum, let's say, the negative 1 and the 24 together right there, they're going to have a sum that's 23 if you add them together. That's going to be negative 23. Here we get 10, negative 10, 5, negative 5, 2, and negative 2 if you add those values together, right? So we want the one that adds up to b, which is negative 5. So we'd want to choose that option that I just circled right there of the 3 and the negative 8, since that adds to negative 5. So what we're then going to do with that is we're going to take the same trinomial that we had, so the same 6x squared minus 5x minus 4. But what we're going to do is this minus 5x right here, we're actually going to rewrite it in terms of these numbers that I circled right here, using the 3 and the negative 8. So what we're actually just going to do is, instead of writing minus 5x, we're going to write plus 3x because we had a positive 3, but then minus 8x. So just notice that actually, if I were to simplify that right there, it's still the same thing as negative 5x, right? But we've just split it up into those two separate terms. So why? Well, it just turns out that when we pick those particular terms and those particular numbers, we can actually factor this 4-term polynomial by grouping, okay? And that's where this 6th step comes into play, is we're going to use the grouping method. So if I group together the 6x squared and the 3x, I want to look for a GCF of them, and I can take out a 3 and an x. So if I do take out 3x, I'm going to end up with then 2x plus 1 in the parentheses right there. And then with the next group, they're both negative, so I'm going to put plus, and then I'm going to take out a negative. Actually, you can take out a negative 4 from both of them. That'll leave you within a 2x plus 1, which is great, because then you can see that right there and right there, you've got the 2x plus 1 in common. So then you're going to be able to factor this and then have 2x plus 1, which would multiply with the 3x minus 4 in that other binomial. So that would factor that. Now, I guess I should recognize that we did take out that GCF of 3 to begin with. So we'd want to have that 3. And so then, yeah, that would factor that. And of course, you can always check your answer. So if you were to just multiply this all the way out, so if you distributed the 3, you'd get 6x plus 3, and then the 3x minus 4 would be the same. So you'd end up getting, 18x squared. That would be minus 24x plus 9x, which would give you minus 15x, and then 3 times negative 4 is negative 12. So you can see just by checking it that it does work out to still be the same expression, right? You can see at the top of the page here that I've left some room to help bring some insight into why the AC method works. I will come back to that. I think it'd be more wise to just look at some specific examples of using the AC method, and then I'll just jump back so that we can just take a look at that for a little bit. So it does say here that we want to try to use the AC method to be able to factor each of these trinomials. So as we take a look at this first example, if we're trying to factor this, check for a GCF first, like you always need to do when you're factoring. So if we look at the 10, 23, and 6, there's not a greatest common factor other than a 1, so we don't have to worry about that. So the way this AC method works is we want to find that product AC and then find the two numbers that add up to the B. So one reliable way that I like to use when I'm using the AC method is create this little X chart that I'm making right here, where in the top of the X, I'm going to write the product AC, and then at the bottom of the X, I'm going to write the sum that we want of B. So in this particular case, your A number is 10 and your C number is 6. So if I do AC, A times C, you're going to get 60. So I'm going to write that at the top of the X. And then my B number is that positive 23. So I'm going to write 23 down there at the bottom. So what I need to try to find, right, is I need to try to find factor pairs of 60. So I could do 1 and 60 or negative 1 and negative 60, because a negative times a negative is a positive, right? I could also do 2 times 30 or negative 2 times negative 30, or I could do negative 3 times negative 20 or positive 3 times positive 20. I could also do negative 4 times negative 15 or 4 times 15. I can also do 6 times 10 or negative 6 times 10, negative 10, right? So there's a lot of options, but I need to try to find the one that's going to sum to be 23. So like, for example, right there, that's going to add up to be 61. That's negative 61. That's 32, negative 32, negative 23. There's the one right there, right? 3 and 20 add up to be 23. So then I'm going to then just use the 3 and the 20 and just write the 3 and the 20 because those are the two numbers. They're going to multiply to equal 60, but then they're also the two numbers that are going to add to equal the 23. So all that's going to happen is then we're just going to write the 23n, the thing that's in the middle, as plus 3n plus 20n instead of plus 23n. And then we just factor it by grouping. So then we just do 10n squared. And then it doesn't matter if you put the 3n or the 20n because we know that with grouping that you can change the order of stuff. So like if you put the 20 there and the 3 there, it'll still factor by grouping just fine. It's not a big deal. So I'll just put the 3 first and the 20 there, and then we'll just factor by grouping. So then if I put those in the same group, I look for a GCF. So in that case, they have the n in common and that only. So I'm going to take out an n, leaving me with 10n plus 3. And then in that group right there, 20 and 6 have a 2 in common, so plus, and I can take out a 2, and then I end up with a 10n plus 3, and that's great because then they got the 10n plus 3s in common, so it's then going to factor as 10n plus 3 with the n plus 2 right there, and that would give you the factored form of that expression using the AC method, right? So it's pretty slick, pretty nice to be able to use, okay? Another example that I want to look at right here is this fella right here. So this one, we want to check for a GCF first if there is one, and it looks like with a 25 and a 110 and 40, they all end in zeros and 5, so at least a 5. So let's at least take out a 5, see what we were left over. If I take out a 5, I get 5y squared, that'll be minus 22y plus 8. Yeah, and then 5, 22, and 8 don't have anything all in common. So yeah, I guess 5 would have been the greatest common factor. So then, if we're going to factor this further, you could maybe guess and check that one. It's maybe not terrible, but let's go ahead and use that AC method on this. So for the AC method, I'm going to write the product AC, which means 5 and 8, which is going to have to be 40, 5 times 8. But then I'm going to want this to sum to be that number right there, which is a negative 22. So you have to think about all the stuff that times this to equal 40, right? So 1 times 40. You could also do 2 times 20, 4 times 10, 5 times 8, but needs to add a negative 22. So I guess you could choose those two numbers, but you're going to have to really do like a negative 2 times a negative 20, because we know a negative times a negative will equal a positive, and it'll equal 40, and then also that negative plus the negative will equal negative 22. So yeah, it'll work out great. So we're going to be able to factor this then further. So first of all, we'll just do a rewrite of the middle term. So the middle, instead of writing it as minus 22y, you'll write it as minus like 2y minus 20y instead, right? And then you just do the factoring by grouping. So if I group those two together there, you're going to be able to factor out a y from them. So you'll have y times 5y minus 2. And then when I group these here together, I'm going to have to take out a negative because 20 and 8, they both have like a 4 in common. So you'll put a negative 4 on the outside, which means you get then a positive 5y minus 2 there. And then that's great because then we can factor this now because that and that both have the 5y minus 2. So then you can have the 5y minus 2 and then the y minus 4. You still have that 5 GCF that you took out. And then that right there gives you the factored form for that expression using the AC method there. All right, excellent. So some kind of special things to kind of be aware of with these. So right here, they both start with 100 and they also end with 49 or negative 49. So there isn't a GCF for either of these. So if we're going to use the AC method on these, you'll have to recognize that for this one, if A is 100 and B is 49, they're going to have to multiply to equal 4,900, which, holy smokes, is a large number, right? But it's going to have to add to be negative 140. So since 49 is such a huge number, I actually wrote all of the factor pairs of 4,900 over here. So you could do like 1 times 4,900, or you could do 2 times 2,450, right? But we ultimately want to find the pair that's going to add to be negative 140. So I guess both of them are going to have to be negative. So it turns out that I think the option that's going to work is that one right there, the 70 and the 70. 70 times 70 does equal 4,900, but then they're going to add a negative 140 to make them both negative. So we're going to have to do actually negative 70 and negative 70. So then using the AC method on this, then we're going to have to write this as 100c squared, and then we split up that middle term. So instead of negative 140 CD, we'll have to write it as minus 70 CD, and then minus 70 CD again, because they're both minus 70s. and then at the end right there we'll have a plus 49d squared. So then we just use the factoring by grouping, right? So we group those two things together, and then we got to find what they have in common the most, right? So 170, they're going to have a 10, and then c squared and cd have a c, so we can take out a 10c. That's going to leave you then with 10c minus 7d in the parentheses. And then if I group these other ones here together, you're going to have to take out a negative, so you get the signs to all match up. So the first one's positive, the other one's negative. So 70 and 49 both have like a 7, so we're going to take out a negative 7. And then CD and D squared also have a D, so we can take out a negative 7D from both of them. And that'll leave you with the same thing of a 10C minus 7D, therefore. So because you have the 10C minus 7D in common, then you can take out that is the common factor from both of those terms, and you'll also end up with the 10c plus the negative 7d, so 10 minus 7d, and then what you'll realize is like, oh, hey, it's 10 minus 7d and 10 minus 7d, so it's actually, right, just, 10c minus 7d squared, and so that does indeed factor that as that. And then just one more example using the AC method here. So you can see that actually we're going to end up with a negative 4,900 because your A is 100 and your C is negative 4,900. But then we're going to have to find the one that adds to negative 225. So just based on the chart that I found right here, it actually turns out that you have to use those couple of numbers. But you're going to need to make sure that you make that 245 there negative. So it adds to negative 225. So then if you just split up that middle part right there, you're going to have to make one of them be positive 20 CD and the other of them be negative 245 CD, and then keep that last 49D squared all the same. And then we can factor this here by grouping all this together. So if we group these here together, 120 both have a 20, and C squared and CD have a C, so you can take out 20C. That means 20 times 5 is 100, so that's going to be 5C, and 20 times 1, so that's just going to be 5C plus D, I guess, yeah. And then if we group those together, they're both negative, so you're going to have to take out some sort of a negative. It does turn out you can actually take out a negative 49 because it can times 5 times to equal 245. Oh, and then I guess you can also take out a variable, so not just a negative 49, but there's a CD and a D squared, so you could take out a D as well. So you end up with the same 5C plus D in the parentheses once you do so. So it's just kind of a final result then that 5C plus D would multiply to the binomial that has the 20C minus the 49D. So that right there would get that factored all the way down there using the AC method.